Okay, we're now looking at question 9 and discussing asymptotes, etc. from the graph of y equals 1 on f of x. First thing, we've got our function x squared plus 4x minus 5, so we'll work out the x-intercepts on that, and of course that's going to be plus 5 minus 1. Therefore, since that's the intercepts, if you would draw a parabola, the parabola would look something like this. It would go through 1, it would go through negative 5, it'd have a turning point at negative 2, which is halfway between negative 5 and 1. And if you substitute negative 2 into the function, you'll get 4 take away 8, which is negative 4 take away 5, which is negative 9. Therefore, if we look at 1 over f of x, there'll now be an asymptote at negative 5. There'll be an asymptote at positive 1. We'll get a function turning like this and 2 wings like that. So if you look at the options that are correct, there's an asymptote at negative 5, positive 1. There's always an asymptote at 0. So answer B is the correct option. Right. Answer A, they've messed up the signs, or they haven't converted the signs for the asymptotes. Answer C, it looks like they've actually inverted the intercepts, so 1 and 5 become 1 negative fifth, so that's wrong. And D and E is actually a mistake, as a typo. Those turning points should be at negative 2. They've made a mistake, simple mistake, and put negative 1. Question 10. The coordinates of the centre and the length of the semi-major axes of an ellipse. Well, first of all, because you've got x plus 2 and y minus 3, the centre will be negative 2 and positive 3. And then we're looking at A is 5 and B is 4, square root of 25. Right, the length of the major axes. All right, so when you do A is the length of the semi-axis, which is from the middle to the edge. So that would be 5. Therefore, another 5 there. The total length of the major axes in this case would be 10. So we're looking for negative 2, 3, and 10, which is answer E. And the others, you'd explain B and C wrong because they've used the semi-major axes instead of the major axes. And the other two, you'd talk about incorrect centres. Now we're moving into trigonometry. So we're talking about the inverse cos of sine of 7 pi on 6. Alright, so that becomes the inverse cos. 7 pi on 6. Alright, 7 pi on 6 would be in the third quadrant. So sine in the third quadrant is a negative. The base angle is pi on 6. The sine of pi on 6 is a half. So really that statement is asking you for the inverse cos of negative a half. Now, the angle for cos that gives you a half is pi on 3. Where is cos negative? Cos is negative in the second quadrant. Therefore, my final answer is 2 pi on 3, which is D. As with all these trig questions, you would normally reject the other options because of either being in the incorrect quadrant, such as A and B, and then C and E is more discussion about the fact that the person does not know their exact values. Common mistake we all make. 12 is irrelevant. Alright, we're not part of the course. 13. The implied domain for the function inverse sine 3x plus 1. Careful here. This time my base angle is 3x. That's the only thing that's there. Imagine there was a bracket there. It hasn't put in it, but that's what the same thing is. To work out the domain, you substitute it between negative 1 and 1. We divide through and we're going to get negative a third to positive a third inclusive. And so that answer is B. Okay. A looks like they've multiplied both sides by 3. Right, there's no E is wrong because what they've done is actually work out the range, and they've added 1 to the normal range of negative pi on 2 to pi on 2. And C and D, with some incorrect manipulation, looks like they've taken away 1, etc. So 14. Cosec x is negative 3. Alright. Soon as you see a trig function, they've given you quadrants. Draw a triangle. Answer x. What is cosec? Cosec x is negative 3. Cosec is the reciprocal of sine. That means sine x is negative 1/3. Sine is opposite, negative 1 over hypotenuse 3. By Pythagoras, 9 take 1 is 8. This will be 2 root 2. Now we're looking for the value of cot x. Cot x is, instead of opposite over adjacent, it's adjacent over opposite. So it'll be 2 root 2 over negative 1. So negative 2 root 2, which is option E. And then you'd knock away all the others, because 1, they would have probably found. C is wrong because they've done tan instead of cot. D is wrong because they've probably just drawn it in ignored the negative, drawn it in the wrong quadrant. And the other 2 you can explain away, again, not understanding the base ratios. And last of all, 15, sine x is 4/9. Again, an angle, a ratio is mentioned, a quadrant is mentioned, draw a triangle. Don't think, draw a triangle. 4/9. So you have 81, take away 16, so that'll be root 65. We're after cos 2x. There's a variety of ways of doing it, but cos 2x is 1 minus 2 sine squared x. It's always best to work out values with things that you already know. So 1 over 2, 4/9 squared. 1 minus 2 times 16 over 81. Okay, so that's 32 over 81. So 81, take away 32, 59, 49. So we're going to get 49 over 81, which is option C. And then I would just knock away some of the others explaining things. So A, that looks like they've just forgotten to square root, and they've done cos of x, 65 over 81. So cos 2x, they've actually just squared the function. 2 root 65 on 9 means they've doubled the cos value. So cos is root 65 on 9, and they're thinking that 2x is just 2 times the angle. And the others you can knock away. They've done some incorrect calculations. But that'll do for now.